Guys, let's have today's Lead Code Daily Challenge. Today was the day 5 of February. Yes. Actually, the question was check if one string swap can make equal. Okay. You are given two strings S1 and S2 of equal length. A string swap is an operation where you choose two integers in the string, okay, and swap the characters of these integers, okay. Not necessarily different, okay. Okay, return to is possible to make a string equal to performing the operation at most one string swap on exactly one of the strings. Okay. Okay. Yes, actually the question was we can okay. Actually the question was we need to make the two strings as equal. Um, and then we can able to perform the operation at most once the operation was we can choose either of the strings. Let's take a string S1. What we can do is we can able to choose the two integers and then we can swap those integers. After swapping, both the string has to be equal, right? Um, in the question they have given that we can able to choose any of the two strings, but we can straightforward we can directly go with the string one after because the operation completion depend on the swapping any of the two characters at most once, so that taking the any string will give us answer. So we are just going the string one. We can check whether actually the overall string length was controlled. Okay. The brute force approach was choose we can directly choose all the possible integers by traversing the n squared approach, and then we can swap those integers. After that we can check whether those whether these two strings are equal or not. Actually the time complexity of this approach was choosing the all possible integers will be straightforward, which gives us 1 power, sorry, which gives n square, and then after that after swapping when comparing the both two strings which will give, yeah, for all the possible n square operation we are just comparing the both the strings, and then the comparison will give overall complexity of the size of the string, so that the overall complexity will be depends on somewhere in between n square to n power 3. Yes, it's work, right? Yes, actually it work. And then the most optimal one was given that we can able to do this operation at most once, so that the number of different characters in both the strings has to be 2. Yeah, the number of different characters without swapping at the initial time, the number of different characters in the both the string must has to be 2. And somehow if we can able to store these two characters, what was the different characters was there in string 1 and what are different characters was there in string 2. What we can do is we can store B and K, and then we can store B, and then we can store K and B, and then we can directly check if these two characters in this set and then these two characters in the sets are equal or not. If it is equal, we can directly say yeah, we can able to make the two string equals by doing this operations. In this question the different characters was different characters was A and B, and then the different characters was P. T and E, and then the different characters was again and T and F, yeah, and so on. It's actually violates the condition, so we can take this as example. We can take this example, and then we can say okay, the different characters was 0, right? So yeah, these are the best figures. And the time complexity of this approach was big O of n, in this case was also big O of n, right? Yeah, that's it. Now we need to store these two strings. Yeah, at first what we need a set to store the two characters. It's a cat. set 1. This access set 2, and then given that the both the string length was equal, so we can take the length of the string 1 as size. If my both the characters was not equal, we can add it to the first character to set 1. The same way we can add the first two characters to string 2. We can check, before that we can check if the set 1 size was already okay. We can actually check if set 1 size was greater than 0, which means that already the two different characters was added in the set, so we can't able to swap this again, right? No. Yeah, so we can't able to swap this again. Let's in this case the only two characters are different, so if we can able to swap these two characters, then we can able to achieve. So let's say we're having a one more difference in this way, so we can't able to make these operations, right? So if we need to make this operation, we need at most two swaps. Yeah, so what we can check is if the size of the set 1 was greater than 2, we can simply return yes, that is no possibility. Yeah. Somewhere we can store it like 3 set or something else. Yeah, store it at 3 set. We can return if my set 1 size, either my set 1 was empty. What does that mean? If the set 1 was empty, which means both the string was already equal. Or what we can say, if my set 1 was equals to, yeah, that's it. Yeah, actually we are just storing a 3 set to store. Wait a minute. It's giving us a wrong solution. No way. Am I wrong? Oh yeah. I actually made a mistake there. Yes. Actually, the 3 set doesn't work right. We need to go with other index, because what if there occurs a duplicate number of characters, which is also there is a possibility, right? So we need to sort this. Yeah, and then we need to sort this again. This set to, yeah, silly mistakes. Again, no way. Am I missing something? Yes, both the characters was not equal, and both the characters was not equal. Yeah, and then yes, V and S was also not equal, right? What am I missing? I don't know what am I. BSB. Okay, no. If it was okay, I just missing the edge case. The size has to be, if it is already 2, we need to return directly. Yeah, one more thing, edge case. That's it. Thanks for watching.